our group did problem number 3. This is the introduction and background. A square is composed of 4 sides that are equal in length. When a square is divided along the diagonals, each of the 4 sections created have the same area. The problem: how does changing the position of the endpoint along the right side of the square affect each of the 4 areas? How did we solve it? We will be using a ruler to measure side lengths and heights of triangles created by the diagonals.
Let's say that you are creating blueprints for a square garden in your yard. You want to plant 4 different fruits and vegetables: watermelon, strawberries, carrots, and tomatoes. You start your blueprints using a square with equal sides, each of 4 inches.
Using diagonals, you split up your square. By doing this, you've created 4 sections, all of equal size, each 25% of the whole square. However, you know that different plants require different amounts of space to grow. By changing the endpoint of the right side of your square, you are able to manipulate the area of each of the 4 sections. Let's call these sections A, B, C, and D, as seen on the screen. Using a ruler, you start by changing the endpoint to 1/2 inch. To calculate the area of each section, you measure the heights of each triangle. Heights are seen as a dashed line. Then, using the formula for area of a triangle, half base times height, you calculate the area of each sections A, B, and C. To determine the area of section D, you subtract the areas of A, B, and C from 16, the area of the whole square.
Now we change the positions to an inch. Using a ruler, we measured side lengths and heights of triangles. Then using these measures, we again determine the area of triangles A, B, and C, as seen in the screen. Area of section D, we subtracted the areas of sections A, B, and C from 16, the area of the whole square. We already found the areas of the endpoint 1 and 0.5. Now, to repeat these steps for the positions, we did the same process from 4 to 0.
As the position decreases, starting at 4, going down to 0, the area of A increased from 4 inches squared to 8 inches squared. Area of A increased to 8 square inches, which is 50% of the whole.
As the position decreases, area of B also decreases, leading to 0% of the position and area of B. On the graph, position makes up the y-axis, while area of section C makes up the x-axis. With regards to section C, as the position of the endpoint along the right side of the square goes from 4 inches to 0 inches, the area of section C becomes smaller and smaller until it reaches 0 inches squared, and thus makes up 0% of the whole square. What happens to the area of section D is almost the opposite of what happens to sections B and C. As the position of the endpoint along the right side of the square goes from 4 to 0 inches, the area of section D increases until it reaches 8 squared inches, and thus makes up 50% of the whole square. In conclusion, as the endpoint position along the right side of the square decreases, going from 4 inches to 0 inches, the area of section A increases to 8 squared inches, making up 50% of the whole square. This same thing happens to the area of section D. In contrast, the area of section B decreases to 0 inches squared, making up 0% of the whole. This same thing happens to the area of section C.
The application to the garden problem. You did some research and found out that watermelon require the most space to grow. Strawberries require the second most amount of space, carrots the third, and tomatoes require the least amount of space. Using the endpoint 1.75 inches, best divide sections A, B, C, and D so that each fruit or vegetable gets the appropriate amount of space to grow.